As we continue advancing in math, we want to look at things in deeper and deeper ways. So in this video, we're going to be deriving the remainder theorem using the division algorithm. Our division algorithm says if f of x and d of x are polynomials, with d of x not equal to 0, and the degree of d of x is less than or equal to the degree of f of x, then there exists a unique polynomials q of x and r of x such that f of x equals d of x times q of x plus r of x. The remainder r of x equals 0, or it is of degree less than the degree of d of x. If our remainder r of x is 0, we say d of x divides evenly into f of x. If r of x is equal to 0, we say d of x divides evenly into f of x, and d of x and q of x are factors of f of x. Well, that sounded kind of complicated, but this is something that we use like every day when we divide numbers. This is the basis for a lot of things. So let me try to explain it a little bit more simply here. Let's do it with just some numbers. So say we have the number 48, and I divide it by 5. 5 goes into 48 9 times. We multiply back, subtract, and get a remainder of 3. So what our division algorithm is saying, and I'm just going to line up the numbers right under this division algorithm, is that 48 would be equal to 5 times 9 plus 3. So our original number, our original polynomial, is equal to the divisor times the quotient plus the remainder. And that's exactly what we had over there. Now, if we took our number 48 and we divide it by 6, and it goes 8 times, and we get a remainder of 0, if our remainder is 0, then we say that both d of x and q of x, our divisor and our quotient, are both factors of our original f of x, and that's true. We would say that 6 and 8 are factors of 48. So it's something that we've done a long time, just looking at it a little bit deeper. So now let's consider the division algorithm when the divided f of x, so we're going to take f of x, we're going to divide it by x minus c. In this case, the remainder must be a constant because its degree is less than 1, which is the degree of x minus c. So we know that when dividing polynomials, the remainder is also always a lesser degree than the divisor. So if the divisor itself is first degree, that means our remainder has to be 0 degree, which is a constant. All right, so if we do that, and using our division algorithm there, we're going to get that f of x is equal to x minus c times q of x plus r. So let's evaluate f at c. F of c would then become c minus c times q of c plus r. And the reason we're not writing r of x there is because we know that it's a constant, so there's not going to be an x involved, so we're just writing r instead of r of x. F of c is going to be equal to c minus c is 0 times q of c plus r, and then 0 times q of c cancels out to be 0, and we get that f of c is equal to r. Well, there is our remainder theorem. Remainder theorem says if a polynomial p of x is divided by x minus a, then the remainder is p of a. And we proved that that's true. We'll continue to use remainder theorem as we build throughout this unit.